Welcome to part 2 of our notes on energy. Now, part 2 is going to be taking a look at some more of the fill-in-a-blank notes. Again, make sure you have the fill-in-a-blank notes. It'll make taking notes a lot easier. But we're going to take a tour. One of the themes that you've seen happen quite a bit this year is Mr. Phillips and I have taken a lot of tours of a lot of facility. We've done a lot of research. So we don't want to just tell you about energy and power plants. We want to show you some of our local features that we have here. Now, one of the first places we're going to take you is Columbia Power Station. Columbia Power Station is located just south of Portage on Highway 16. And it's one of those neat things. If you ever go out Highway 33, and it goes straight for quite a while if you're heading east towards Portage. And before you make that bend, if you look off over in the horizon, a lot of times you can see these two stacks that you have. And these two stacks, well, here, let me do this. Let me get a pen. These two stacks right here, if it's a colder day, you can actually see smoke coming out of the stack. And although I'm going to call it smoke, it's really not smoke. Most of it's steam. And you can see that. So next time you head east out of town on Highway 33, look for those. That's the Columbia Power Plant. If you get into Portage, when you get to the first stoplight there in Portage for Highway 33, if you take a right, you'll actually go by these eventually. It's on the south end of town. Now, Columbia Power Station is located just south of Portage on Highway 16, and it burns approximately 12,000 tons of coal. And it gets this coal from the Powder River Basin in Wyoming, and it burns 12,000 tons every day. Now, Columbia Power Station produces approximately 1,050 megawatts of electricity from 2 generators. And it sends this electricity into the electrical grid. And we talked about the electrical grid in part 1. And there's 2 lines that head towards Madison and 1 line that eventually heads towards Fond du Lac. And some of this electricity is also sent into Portage, but most of it's sent into these other transmission lines. And it generates electricity 24/7 except for a yearly 3-week shutdown for routine maintenance. So whether it's in the morning, whether it's at night, it's not like a typical factory where it's going to produce electricity for 8 hours a day. And a lot of factories will shut down. This operates 24/7. Now, when you look at these transmission lines that leave, there's actually 2 right here. The smaller ones off to the left right here, these are the ones that head into Portage. But these larger lines, these carry approximately 345,000 volts. And this one right here is actually headed towards Fond du Lac, Wisconsin. And again, the smaller ones head towards Portage. And if we were to follow these tracks, Portage is probably about 3 or 4 miles in this direction. It might be a few more miles. It seems like it takes a while to get out there. But the speed limit right there is 45 miles an hour, quite a ways. So I would say approximately 3 to 4 miles till you get into town. Now, this is one of the 6-unit trains that serves Columbia Power Station, and it takes about 6 days round trip to go from Wyoming and back. And I think the next slide, here you go. Well, let's take a look at this slide. Do you see how many engines they have? And this tells you how much coal they have. They have 1, 2, 3, 4 engines carrying this. And this is called a unit train, and there's 115 cars per unit train. And each of these unit trains contain 14,000 tons of coal, and that's approximately enough for 1 day. If you remember from a couple slides ago, I said that Columbia burns about 12,000 tons of coal a day. So this is 14,000. So if they can make 6 trips, well, they're going to have that extra 12,000 tons of coal. So they actually have enough. They can make 6 of these trips. So basically every day, 1 of these is coming into the Columbia Power Station. Now, Columbia burns approximately 4.5 million tons of coal per year, which is a unit train per day. The coal comes from the Powder River Basin near Gillette, Wyoming. And one of the reasons why we get it from Gillette, Wyoming, when I say we, why does Wisconsin, why does the Columbia Power Station? They get it from Wyoming because it's lower in sulfur and it's cheaper than South Illinois coal. It's, at the time, this was several years ago, was about $6 per ton. And the lower sulfur in the coal means less pollution going out the smokestack. And they do not need to use scrubbers before burning the coal. Now, one of the things I want to do is caution you is I believe some of this stuff has changed since we toured the place. I do believe they use scrubbers now, or they're in the process of putting them in. And so they are doing quite a bit to make the coal that they do produce, or they don't produce the coal, but the electricity they produce, one of the byproducts of that is some pollution. And it doesn't matter. If you're going to burn coal, you're going to get some pollution. But the trade-off is we get electricity. So there's always trade-offs. And so they are working on lowering the amount of sulfur they do put into the atmosphere. Now this is a pretty neat shot. When we were there, we actually got a tour by Mr. Bergman. Hello, Mr. Bergman, if you are watching this. And he did a phenomenal job. He showed us all different parts of the plant. And one of the neatest things that I enjoyed was he took us up to the roof. And one of the things we were able to do is we were able to look down. And this may not look very large, but this pile right here is actually about 500,000 tons of coal. So it's hard to see, but it's actually a big hill of coal. And it's enough coal for 35 to 37 days. And I've heard since we've been there, they actually have enough coal for longer than that. And some people say, well, why do they have so much coal? Look at how much space that takes up. Well, you never know what's going to happen. What happens if the railroad tracks gets wrecked, or if there's a train wreck and they can't get coal for 2-3 days, maybe a week, maybe 2 weeks. They want to make sure they have enough coal to produce electricity uninterrupted. The other thing I want to point out is this part right here. This is the beginning of a long conveyor belt that brings that coal into the power plant. So here we can see part of it, and here's the rest of it. So it's basically a long conveyor belt that brings the coal in. And this next slide is actually, the entire section is about 3 football fields long, and so it came in way over here, and this conveyor belt is again bringing that coal in. You can see it right there, and what it's doing is actually dropping it into silos. So these two conveyor belts, there's actually 2 of them. They transport 800 tons of coal per hour to the feeder silos for each of the boilers. And these conveyor belts are filling the silos. Now these silos, they're always kept at least 50% full. And some people might ask, well, why don't they, run one of them? Why don't they let it run out? Then they go to the next one. Well, they always keep them at least 50% full just in case something happens. What happens if one of the conveyor belts breaks? What happens if both of the conveyor belts break? Now, they're going to try and get them fixed as quickly as possible. But even if they're broke for a few days, they have enough coal in the silos to provide electricity uninterrupted. So they can't afford to wait until the last minute. They can't afford to let all the silos empty out and say, oh, we'll just fill them the next day. They're going to keep them at least 50% full, if not fuller, so if something happens, they have enough coal to keep the power plant running. Now here are 5 of the 6 silos, and each of these silos holds 6,000 to 7,000 tons of coal for the boilers. So you can do the math. If Columbia Power Plant burns 12,000 tons of coal per day, it would take approximately 2 of these to provide enough coal to keep them running. So by keeping them at least 50% full, you're going to have enough for several days, even if both conveyor belts break down. Now this is the bottom of one of the coal silos. And one of the interesting things that happens to this coal, it's not like you're burning charcoal where you burn the big chunks. Right here is actually a coal pulverizer. And what happens in the coal pulverizer is the coal gets pulverized. That's why they call it a coal pulverizer. And it grinds the coal into a fine powder. And it's this powder that gets burned, not large chunks of coal. And so here the coal dust is sent through these pipes. They have a vacuum system that's pulling the coal dust up. And they actually blow that into the boiler, and I'll show you that in the next slide. Now this was one of the neat pictures that we took. This was in Mr. Bergman's office, and this would be a scale model. So this would be a person, say a 6-foot tall person. So you can see how large of a scale this is. Now if you ever take a tour of this place, and they don't offer daily tours to just anybody, but if you did, when we were walking way up here, they didn't have cement floors. We were walking on grading. So when we would be walking over it, we might be looking at something 50, 60, 100, 150 feet down. So if you're not good with heights, this is probably not someplace you want to visit or someplace you want to work. Now this design is considered to be a closed loop system, which means the water that runs through here does not come in contact with some of the water you're going to see later on that goes out into the lake located right next to the power plant. So here Mr. Bergman actually showed us, that's his hand, So if you're watching, Mr. Bergman, do you recognize your hand? And he actually opened it up, and it was an interesting design. First of all, inside the boiler, it's approximately 2,500 degrees in there. And this whole design is a negative draft design. Air is pushed into the boiler to control the temperature and pressure. And the reason for that is if someone was, say operating a forklift or operating a power tool, and if they were accidentally poke a hole in here or drill a hole in here, they didn't want the fire coming out. So by creating a negative design, even when he opens this door right here, the air from everywhere in the plant will go into the boiler. So it's to prevent accidents. Now, one of the neat things we could do is we could actually look down in here and we could actually see where they're blowing the dust into this boiler and where it was actually igniting. So that was really neat to be able to see that. Now, this is a super steam heater, and this is at the end of the boiler, and this heats the steam from 650 to 1,000 degrees for the turbines. And again, I apologize, you can't see the bottom of the notes here, but it's the best I can do using Screenomatic. Now, this is one of the sets of turbines, and there's also a generator here. So we looked at this in part one. So you have your steam coming through. You have your high pressure steam, you have your low pressure steam, and here's your generator. So that steam is spinning the turbine, and there's a shaft that goes through here, and that shaft goes into the generator. Now, Columbia Power Plant, this one produces 525, and if you remember, I said Columbia Power Plant produces 1,050, and that's because there's actually two of these. So this whole power plant, the whole thing, is all designed for this right here, to get that shaft spinning inside the generator to produce electricity. Now, one of the other things we were able to look at from the top of the power plant is this huge lake. And this is an aerial view of the 500-acre cooling pond, and taken from a top Columbia Power Station, approximately 300 feet above the ground. And what happens is the water's got to cool. And this water basically takes a giant loop around here, and it comes back into the power plant over here. Now, one of the interesting things, because it does come from a power plant, it's heated water. Now, it's not going to be 90 degrees, but one of the interesting things is it doesn't freeze in winter. So you can actually go fishing on here. Over here, and I'll show you what it looks like over here. I'll actually take a picture of the power plant over here. There's a spot where you could park, and you can, walk around, and you can actually go fishing on here. The Wisconsin River is just a little, you can kind of see it over here. It's blue. So here's your Wisconsin River, and so by having this giant pond, they're actually able to cool the water. Now, the day that we went, it was probably about 90 degrees outside. In the plant, it was about 120 degrees. And so these were also working. These are cooling towers. So a lot of power plants that you have cooling towers, and they don't have this huge lake. Columbia actually has the huge lake, so they don't have to always operate the cooling towers. If you didn't have a lake, power plants would always have to operate the cooling tower. And basically what happens is instead of all the water going into the pond, the water will come through here. They're going to blow air through it here, and basically it cools off the water again before it goes back into the plant over here. Now, one of the interesting things, so here's the other side of the lake where I was drawing before, and this is where we actually took some of those pictures from. So we got to go way up here. Here's that long 300 this conveyor belt that was 3 football fields in length. So it's not just, this isn't 3 football fields in length, but the conveyor belt, it goes in here, comes around, and loops back around. Now, the two smokestacks, some people will ask, why are there two smokestacks? The smallest one, and the way we took the picture, it's hard to see because they're both lined up, but here's the shorter one, here's the taller one. Well, the two smokestacks are 500 and 650 feet tall, and they're actually 25 feet across at the top. So that's almost the length of this classroom that I teach science in across. So if you're in my classroom watching this, imagine a smokestack being that large across. You could drop a car down here. And so it tells you how large these are. And one of the things that was interesting is that when they built these, because they were built in different years, the regulations required them to be different heights. So there's two smokestacks here because there's two different power plants all underneath the same roof. and the steam leaving at the top is about 250 degrees. So if you're driving by here in the winter and you see a lot of stuff coming through, I know a lot of people think, wow, look at all that pollution, look at all that smoke. Well, there is going to be some pollution in there. Again, you cannot burn coal without producing some pollution. But a lot of that is simply going to be the steam that's coming out of the top of the tower. Now, these are some step-down transformers, and they drop the voltage down. Remember I said one power line goes in the portage? So when the power comes out of the power plant, it's at 22,000 volts, and they'll drop it down to a safer voltage. They'll set it in the portage, and then it'll be dropped down even further before it goes into a house if you live in Portage. Now, they also have step-up transformers, and these will change the voltage from 22,000, and it will jump it up or step it up to 345,000 volts. And it was interesting. Mr. Phillips and I, when we were taking a tour, after the tour we went and we took the picture from the far side of the lake, and we actually drove underneath the power lines, and we actually got out, and it was kind of eerie in a way, because when we were outside, you can't hear them if you're in a car, but if you turn off the car, you step out of the car, you can actually hear the large power lines crackling. And it's kind of an eerie feeling to think that, you know, that much electricity is going through those power lines that it's crackling. And that does end our slides. If you have any questions about our tour, about energy in general, just please ask us next time you see us in class. Thank you, and have a good night or good morning or good afternoon, whenever, you know, whatever time of the day is that you're watching this. Thanks. Bye.